Right, so thank you so much for joining this webinar. It's going to be a great introduction to UAR using ThreeJS by our wonderful AR developer, Ollie. And if you have any questions throughout, we have a Q&A box at the bottom and we'll be able to get them answered for you. And there's also a chat that you can pop some questions in, but there will be time at the end to also ask questions directly. So over to you, Ollie.
Thank you very much. Hello, everyone. Thank you, Priyanka, for introducing me. This is our introduction to UAR using ZapWorks. So if I get started here, first of all, who am I? Just to give some brief background. I'm Ollie Tyler. I'm the augmented reality development lead over here at Poplar Studio. So I work on stuff like our internal and external tools, such as our product visualization units, our virtual try-on units, and our beauty units. You may have seen me around on the creator Slack, helping out, giving advice, and working with you on prototypes. So I've been in the AR industry for a number of years, creating awesome experiences and tools for a range of companies, including previously working for Zappa themselves. So what is UAR? UAR is a tool that gives you access to Zappa's internal computer vision libraries and makes them available in libraries and SDKs along a wide range of platforms and creator tools, such as ThreeJS, Unity, and A-Frame. This allows developers from a range of backgrounds to build AR content using their favorite development environments and languages. Today, we're going to be taking a focus on ThreeJS with React to build a basic project that gives you, allows you to place some 3D glasses on your face in the experience and do some quick animating. So what's on the agenda for today? First of all, it'll be creating your UAR project. This is using Create React app and just quickly get a bootstrap together. Then you'll be adding a model to your scene. And then you'll be adding lighting, masking out the face, and then doing a basic animation event. Later on, we'll also go over some further considerations and things you can do with it as you progress. So just some prerequisites. I'm assuming you have working knowledge of JavaScript, React, and ThreeJS, as this is recommended, but I'll try and explain as I go along as well. Also, you need Node.js installed, preferably the latest version. And then also there'll be time for questions at the end, of course. Also, feel free to message me on our creator Slack. You can just do @Ollie and I'll help out with any sort of questions. I will try and help. Amazing. So you first want to start off by opening up your terminal, and this is where you'll create your project. So first of all, you want to go into your directory you want to start in. So I'm going to choose directory. And I'm actually going to put this in a GitHub folder in my documents. So I can load up my documents folder and then open up my GitHub folder. And there we are, I'm in my GitHub folder. And now I want to instantiate a Create React App Bootstrap using Zappa's React Free Fiber tools. So I'm going to go npx, and I'm going to be using Create React App, of course. And you can name this whatever you want. I'll name it Webinar Demo. And then we're going to be using a template. So --template. And the template we're going to be using is from Zappa, and it's the React Free Fiber face tracking with TypeScript. This will take a while to install, but let it do its thing. It's just going to download the npx, and then it's going to create and instantiate the project. But once it's instantiated and you've opened the folder that it's created, you should have a project looking something like this. I'm opening it in VS Code. But as you can see, this has the basic Create React App features, including just the package JSON, a basic TypeScript setup, and just basic Webpack setup. But the only sort of script we're going to be using today is the app.tsx, and this contains all of your Zappa related goods, such as your Zappa canvas, and then all of the information. So to start off, you have this basic Bootstrap app, which contains a face mesh, which is basically like face paint on your face, which deforms depending on how you move your face. We can actually test this out by going up to the top, clicking New Terminal to open a VS Code terminal, and then running npm start. This will boot up a local server, so you'll be able to test out on the fly. And when you get started, you will actually receive this connection is not private error. This is because it's using HTTPS to use the camera, and so it gives you a privacy error since you have a certificate. But you can just continue through this, you know it's safe. Now, as you can see, straight away, without any code even dropped down, you've got a face tracking template. You can move your face around. You can see it deform around my lips when I speak. And this makes a great base for any sort of UAR project. So let me just place this in a corner so you can see what it looks like as we go, because this will live update. It uses Webpack. Now, the first thing we want to do is we want to take a look at what we're actually making. So we're going to be making sunglasses try-on. So we don't really need a face tracker. A face mesh on top of it. So the first thing we need to do is actually create a loader in order to load our 3D model. So similar to this texture loader here, we're going to do an import. Let me just make the text bigger. There we go. We're going to import the Gltf loader. And instead of from free, it's going to come under free still, but it actually comes under examples, under GSM, and then loaders. And then you'll be able to see a big list of all the loaders here, but we're going to use the Gltf loader. There we go. And this is so you can load in a Gltf file. Let me make this terminal smaller so you can see more. And then what we want to do is we want to create a new variable which will return our loaded Gltf model, which will be our glasses. So what we can do here is create, let's call this sunglasses. And then what we can do is similar to the face map texture is we can use the use loader hook from React 3 Fiber to return our Gltf model. So let's call this sunglasses mesh. And then as I said, we want to use loader. And the first parameter it takes in is our loader. So we're using the Gltf loader today. And then it takes in a URL or a link to your 3D model. This can be locally stored, or of course it can be just given from a URL. And just for ease of use, I'm going to paste in a URL straight from our CMS. You can use any Gltf model you have to hand. And as you can see, it's passed because I haven't passed in the variable, but there we go. You pass in your URL. And now what we want to do is we want to return a primitive object, and that object will be the sunglasses mesh, and then it will be the scene the entire scene that it contains. Close it off now. There we go. We've built our basic component which has our sunglasses mesh in it. And now what we can do is we can move this basic face mesh and replace it with our sunglasses. And there we go. We've got my sunglasses 3D model straight on my face. As you can see, there's three main problems with this. Number one, the sizing and scale is completely off. Number two, the lighting's a bit dodgy. As you can see, it's a bit darker around the sunglasses where I want that to be lighter. And number three, you can see the glasses wings through my face, which is not ideal. So the first thing we can tackle, obviously, is the position and scaling. So what you can do is you can just pass this as a prop into the into the sunglasses primitive. So what we're going to do is we want to set a position. I previously looked at this before making this. So but what you'll have to do with a custom model is have a play, essentially get it to the size you want. You can use something like .GUI to really sort of hone in the scale. But I'm going to be putting the position and then some scaling in here. I'll put it to 0.7, 0.7, and 0.7, and give it that save. And there we go. That fits on my face a lot better now. Now on the lighting side of things, the Bootstrap comes with a directional light already chucked into it, which is great. But I like to always put an ambient light in it because it adds like a base level of lighting. So what this does is fire a light from every single direction, and it just brings up the overall lightness of the scene. So as you can see, my glasses are now looking very nice and lit. But as you can see, we still got this problem where you can see through my face, which is not great. So Zapier actually provides a head mask mesh, which essentially it places down a face and then it uses it as a mask, so it turns it invisible, so objects behind it can't be seen. So what you can do is right up at the top, open up and create a head mesh mask mesh. As you can see, this imports it straight from Zapier React 3 Fiber. And you'll be able to see up here that you've got a face, you've got the head mask mesh there. You can see it there. Next, you need to pass in a tracker group to this. So luckily, this is already set up. it's passed down from, it's a reference from the face tracker. So we can pass it straight in. Let's have a look. There we go. You can no longer see the glasses through my face. Now that's the main, we could leave it there, but I think let's add something that's slightly more exciting. This is just visualizing it on your face, which is a good first step, but let's actually take it a bit further and do a little animation. So I'm thinking what we should do is we should have these glasses start way up in the air out of the scene. And when you click or tap on the screen, the glasses drop down like the meme, just the deal with it meme. So first thing I want to do is actually create a reference to this object so I can reference it through my code. So let's call this a sunglasses ref. There we go. That's a reference sunglasses. Obviously, we haven't actually set a useRef variable for this yet, so it will chuck an error for the time being. But let's call this sunglasses, and then we can use ref. This will actually import it from, oh, not this one. This will import it there from React 3.5, but this is another hook which allows you to reference objects being used. We're not going to pass it anything, but I'll tell you what, we are going to define its type since we are using TypeScript with this. So we can define it as a mesh because it will always return a mesh, and this imports it straight from free. And as you can see here, this imports from free automatically. Cool, now we have our mesh reference for our sunglasses. The next step we want to take is to actually first, let's make a state saying whether sunglasses are either up or drop down. This will always start as not drop down, and then we can change it as it goes. So let's set a variable for glasses dropped, and then we allow them to set the glasses dropped. This is using the standard use state hook. So if you haven't seen anything about this, you can search up the React documentation. They cover it really well on how to use React hooks and use state. So let's chuck in a use state hook, and if the starting value we're going to pass it is false because it's not dropped yet. Perfect. Now what we can do is to use a use effect hook, and the use effect hook basically runs every re-render, but depending on what you pass it. So essentially, this function will run every time this second parameter is changed. So we're not actually going to pass it anything. So it only runs the first time. So it will run only when the initial sunglasses function is, or the only when the user, it will only run when the sunglasses is first rendered. So essentially what we can do here is we can use our standard JavaScript features, such as adding an event listener on the window. So we're going to add a click, and then on our click, what we're going to do is just set glasses drop to true. And also, just to test this is working along the way, we shouldn't write a load of code without testing out. Let's just log glasses dropped. And now what we can do is we can check our Chrome debugger and just say, oh, we refresh to get rid of the errors because that's from not saving in the past. And then we can click, and there we go, we got our glasses dropped. So tapping that changes the state to true, and then it will log glasses dropped. We can close that for now. And now we need to do something when it detects the glasses have been dropped. So React 3.5 also offers a really useful other hook, which essentially runs a piece of code every single frame. So traditionally, I mean, with Zapper, I think it's 30 logs of 30 frames per second. So this will run 30 times every second. Now what we can do is we can check if the glasses are dropped. And also we want to check if the reference is shown. So we're going to say if this is rendered and if it's referenced here. So what we can do is we can check if we have sunglasses by doing sunglasses.current to check if it's currently got sunglasses. And if it does, then what we want to do is we want to drop the sunglasses. So the best way to, well, an easy way to do this actually in one line is to just get our glasses reference, or sunglasses even, grab the current one, and we want to grab the position, and we want to use the Lerp function. And this basically moves between two different points in a vector 3. So an X, Y, and Z. It takes in the X, Y, and Z of the current X, Y, and Z, and lerps it between a different point based on a sort of speed value. So we want to pass this a new vector 3. This is using ThreeJS. So as you can see, this imported up here as a vector 3. And then what we want to pass in, the end position we want it to stay at. So let's actually copy this straight from what we currently have, because that's ideal. I mean, this is exactly how we want it to look. So let's pass it this. And then the speed we want to pass it is, let's just say 0.1 for now. And it's going to render. There we go. And but it's not going to do anything. It's going to be still on your face, and you're going to click, and nothing's going to happen. And that's just because down in this position, we haven't actually changed this to the starting value, which will be way up in the air. Let's just set it to something like 5.15. And I think you saw a little teaser up there. You can see my face. We can do a click, and the glasses come down on my face. As you can see, it's working pretty well. Let's give it one more test. Perfect. It's working exactly how I anticipated. Now, let me just, there we go. So that was a super, super simple look on building a Zapper project using Create Reactor, getting a model in, and then doing some really basic animations. But this is just really a baseline showcase. We haven't even scratched the surface of what can be done with it, from stuff like physics to external animation libraries, all the way into integrating UAR into full games using Unity. And as always, these kind of tools are always updating. There's new features, always regularly updating, and just make sure to look out for them, because there's some really big stuff coming. Current stuff stuff that's just happened is things like face landmarks. So being able to instantly attach things to different aspects of the face. So onto your chin, on top of the head, onto the lip top and lip bottom, and a bunch of other things like that. I'd love to hear any questions.
Thank you so much, Ollie. So yeah, if you have any questions, feel free to drop them in the Q&A box or the chat box. And yeah, I think for me, Ollie, what's the most complicated thing you've built with UAR?
To be honest, I think it's going to have to be our virtual try-on units that we actually have over at Poplar. So what it does is it takes in a bunch of information from our CMS, and essentially it pulls it into a UAR project, which is the technology that we're using for our virtual try-ons, and allows you to virtually try stuff on from your face. It's the connection between our content management system and our project that we have for virtual try-on that's really sort of where the meat of it gets in. I see a question from Laurie on how do you change the transparency of the model. So what you can do is you can actually grab the material from the model, and then you can grab the material from the model. And then what you can do is you can enable transparency by just passing it the prop transparency true, and then you'll be able to use something simple like opacity, and you'll be able to turn the opacity up and down. You can obviously connect this up with sort of lerping or moving in between, like from hiding and showing, and make it have a nice animation just by having a nice sort of lerping animation there. In what scenarios would you use UAR over ZapWorks? So the main thing you would do is so ZapWorks can be limited at times. Well, the problem is you can't use external libraries, such as sort of animation libraries. So ZapWorks really UAR really opens ZapWorks core machine learning and computer vision tools up to sort of a wider audience, especially as developers that have used like React in the past, use ThreeJS. It really opens it up to using those tools.
Is there any size restrictions on doing a WebAR project on top of doing a social one?
There's no size restrictions, but obviously, as usual, you'd want to sort of keep it low. It's the same sort of website loading. You want to keep file size as small as possible, but you can always have a loader and just have a loading wheel based on it. We generally try and keep all models under sort of like 10 megabytes maximum, but we want to keep this project as small as possible. Can you do well tracking and face filters in the same effect? You can actually do well tracking and face filters in the same effect, since you can use you can swap between. So for example, with our tools, we use a mix of different libraries, and this allows you to easily compartmentalize, and especially with something like React, to swap between different tracking methods really simply. This library is, I think you can use it for free. You have to host through ZapWorks though when free, and the licensing plan goes up. You can check the zap.works website to sort of see a bunch of different pricing structures. And I think, Fabio, your question on do I need to pay Zapper to develop it is kind of answered with the last question where you can check zap.works for pricing.
Do you have any recommendations for where creators can get started with some free 3D models and potentially any guides on some sort of animations that they can do just to play around with it?
Without a doubt. So, I mean, learning, first of all, I'll take a look at learning how to do ThreeJS without the AR side of things, because I think that adds a level of complication, especially a new course has just come out actually called ThreeJS Journey. And that is a great resource for learning. There we go. It's a great resource for learning how to use ThreeJS, and then you can use that, and all that skills is transferable into UAR and it's just great. It's a great course. A big recommend.
Great. Well, if there's no more questions, I'd like to thank you, Ollie, for your time, and thank you to everyone for joining. Any links mentioned and this video will also be available after this. We'll email it out to all the attendees who clicked attend on Eventbrite. Otherwise, if you're not already, if you're sign up to Poplar at poplar.studio/creators, and you'll get emailed it in the next creator newsletter, along with all other updates about us. We tend to send them out every 2 weeks. We have some more really exciting webinars coming up, so recommend joining our Slack channel, where you can keep up to date with all our other webinars and events that will be happening. So yes, thank you, and see you all in the next one.
Thank you for having me. See you later. Bye-bye.
Bye.